So once again, with the ideal gas law, we need to be aware whether what our label is, kPa or atmospheres, because it does matter which gas constant we use. Remember, the gas constants are temperatures in kelvins, N is moles, volume, pressure. So, if I have 7.7 moles of a gas at a pressure of 0.09 atmospheres and at a temperature of 56 degrees Celsius, what is the volume of the container that the gas is in? Well, a lot of people want to relate this with our molar constant for a gas with volume. Why can we not do that? Why can't we use 22.4 liters here for a volume? That is with STP. We are definitely not at STP, are we? So we have to use the ideal gas law here to determine the volume. Now, when I have the ideal gas law, you're going to see that I have 5 different values on PV and RT. What I always do, folks, when I am doing these problems, I just line them up. Maybe, if I can get my board to work, I'll line them up. Come on, board. Come on, board. Give me a green light. Give me a green light. We got one. So, I line them up. I say, okay, PV and RT. I just put them off to the side like that, real simple. In order to calculate something, I need 4 out of 5, don't I? I need 4 out of 5. So I go through. Do I have a pressure? Yeah, I do. I have a pressure of 0.09 atmospheres. Well, that tells me if I'm dealing with atmospheres, then I can go back here and say, okay, I've got atmospheres, so I'm using 0.0821 for my ideal gas constant. And my label is going to be liters atmospheres all over K times a mole. Volume, well, volume is what I'm calculating here. That is my unknown. Number of moles, 7.7 moles of a gas. Doesn't matter what gas it is right now. Temperature is 56. But that's 56 degrees Celsius. How do I get something into Fahrenheit? Or excuse me, check. How do I get something into Kelvin? Add what? 273.15 is what we'll use. It's not degrees. So that'll give me Kelvin. So as I do so with my math, 56 plus 273.15 gives me 329.15 Kelvin. Okay, now I've got 4 out of my 5. I write back PV equals nRT. Now I've got to manipulate my equation to solve for my variable, for my unknown. Okay, I'm looking right here that my unknown is volume. So in order to get the volume by itself, I divide both sides by the pressure. It's a nice, simple algebra equation. So, if I come in here, here is my equation. V is equal to nRT over P. Plug in numbers then, folks. V is equal to N is 7.7 mole. R is the ideal gas constant. Okay. T is the temperature. 329.15. And let's see, my label here is liters, atmosphere, over. And all of this is over my pressure. Now, it's a little tougher to see, but as I'm doing my cancellation, my moles here, moles on top, moles on bottom, that'll cancel. Atmospheres on top, atmospheres on bottom. Kelvin on top, Kelvin on bottom. So I'm stuck with a label of L, which should be my label for volume. It is, liters. So when I do my math, I put it all together. And I come up with a value of, whoops, my volume is equal to 2311.99 liters. I go back, I need to sig fig, so I come back and I see 22. Oh, there is one sig fig here. All right, so I need to have one significant figure. So my volume in sig figs is going to be 2,000 liters. Questions for this one? Let's move her on down. Move on up. Okay? Here is one. I'll let you go ahead and copy down the question first. Then we'll roll with it. If I have an unknown quantity of gas at a pressure of 121.6 kPa, a volume of 31 liters, and a temperature of 87 degrees Celsius, how many moles of the gas do I have? Once again, I just use my setup. I write everything down. I write it all down. Let me get my page up here a little bit. I write it down. P, V, N, R, T. I need to have 4 out of these 5. Okay? I have a P, 121.6 kPa. Now, you can see that we're dealing with the other pressure value. So I look back up here, 831. 831. So my R is 8.31. 8.31 liters times kPa over K times mole. Do I have a volume? Yeah, I do. 31 liters. I am calculating the number of moles, so I must have a temperature. I'm going to convert my temp into Kelvin. And I get 320. I knew that was something because, right. I'm looking here and I say, how can it be less than my last one? Well, because I typed in 237, not 273. Okay, 360.15, that sound better? Now, once again, PV equals nRT. What am I solving for? N. So I divide both sides by RT. This cancels. So N is equal to PV over RT. Well, what is P? 121.6 kPa. What's V? 31. R is my gas constant, 3.81 liters kPa. PA over Kelvin mole. Multiply that by temperature, which is 360.15 Kelvin. As I get through to doing the canceling, top, bottom, on top, on bottom. So I am going to get my answer, when I divide it all out, it's going to be in moles. So I take 121.6, multiply it by 31, and I divide by parentheses 8.31, 360.15, close them, and I come up with, nice, a value of 1.2595 mole. Now I need to sig fig that value. I look back at my original problem, 4 sig figs, 2 and 2. So I'm going to put this at 2 sig figs. Okay, my 5 is going to round up. So my N is going to be 1.3 moles. Final answer. Questions on this one? Now, this I'm not going to do. This I am going to do. This guy right here I am going to do because this is a different type. So go ahead and copy this down, then we'll roll with it. What is the volume of carbon dioxide produced at 37 degrees Celsius and 1 atmosphere of pressure when 5.60 grams of glucose is used up in the reaction? Okay, so right there, we have the reaction of glucose plus oxygen yielding carbon dioxide and water. Okay, what is that reaction right there? Do you remember it from bio? Okay. You remember it from bio? Huh? Cellular respiration. It's the reverse of photosynthesis, all right? So we got cellular respiration. Why did they give me an equation? My last two did not have an equation, did they? Why all of a sudden do they plop up this balanced chemical equation? Huh? I need to be able to find the moles. They're asking about carbon dioxide, but they're giving me glucose. Can I convert grams of glucose into moles of carbon dioxide given a balanced equation? Absolutely. That's stoichiometry, folks. That's stoic. So the very first thing that I have to do is I have to go mass to moles. So I have 5.60 grams of glucose. I do my conversion box. I don't think it's going to be that long because I'm only going to have 2 boxes, but I've already calculated my molar mass, so let me find that. Okay, my molar mass is 180.1572 grams of C6H12O6 is 1 mole of C6H12O6. My grams cancel. I find my molar ratio, and I see that 1 mole of glucose is 6 mole of CO2. Moles of glucose cancel. Now I have, when I do the math, 1865 mole of CO2. So I've converted this into moles of CO2. Now I need to throw that into my PVNRT. Well, I know N is 0.1865 mole. I just go through, back up, okay? Pressure, yes I do, 1 atmosphere. Volume, what volume? I'm calculating. R, which R am I using? Which R am I using? Left or right? Left, because I have atmospheres. Okay? So I'm using the left, 0.0821 liter atmosphere Kelvin mole. Finally, temperature, 37 plus 273.15, 310.15 Kelvin. Now I just have to throw this into an equation. PV equals nRT. Once again, we've done this before. So my pressure, I divide by both sides. My pressure there will cancel. So my volume is equal to the moles times the constant times the temperature. So volume is equal to my moles, 1865 mole, times my constant, times my temperature, all divided by my pressure, which is 1. Do my canceling, moles cancel, okay? Atmospheres cancel, Kelvin cancel, leaves me with the liter. As I go through and do my calculation, my math came up with my volume is equal to 4.7489 liters, but I need to sig fig that 233. So my lowest number of sig figs is 2, so it's going to give me 4.7 liters. So in this particular problem, I needed to run some stoichiometry in order to get the number of moles so that I could plug that into this particular equation. Now I've got one more that I'm going to work, and that's going to deal with PM equals dirt. PM equals dirt. That's how I remember that. Post-mortem, you're under the dirt. The M is the molar mass of a gas, and the M is in grams per mole. D is the density. D is the density. This states, what is the density of a gas with a molar mass of 100 grams per mole at 5 atmospheres or 0.5 atmospheres and 27 degrees Celsius. So just like the other one, I've got some different things here. Okay? I've got different things here, but it's going to be similar. I'm going to set it up the same way. I'm going to work it the same way. I'm going to go P, M, D, R, T, because I have to have 4 out of the 5 of these. Okay. So, I have P, 0.5 atmospheres. So if I have 0.5 atmospheres, that tells me down here that R is 0.0821 liters atmospheres over Kelvin mole. I use the value that has the atmospheres. Okay. I have a molar mass, 100 grams per mole. I do not have a density. I do have a temperature. I do have a temperature, and my temperature is 300.15 Kelvin. I take the Celsius and plus 273.15. Excuse me. So, I bring it back into my equation. If I'm post-mortem, I'm under the dirt. So I am solving for D. So I divide both sides by RT. So my R's and my T's cancel. So D is equal to PM divided by RT. Now just plug them. D. What is P? 0.5 ATM. What is M? 100 grams per mole. What is R? R is my constant. And last one, T. So if I go through, there's an atmosphere that cancels. There's a mole. There's a Kelvin. So as I can see, I'm going to have grams over liters. Is grams over liters an appropriate label for density? Yeah. Yeah, it is. When I do my math, I get 2.029 for my density. I go back and I know that I have 1 sig fig, 0.05. My 100's 1. So it's just going to be 1 sig fig. So my density is going to be equal to 2 grams per liter. Now, I want to just tell you one final thing about this one. Okay? One final thing about this. Let me get this all the way up here. P, M, D, R, T, right? Could I substitute the density? What is density equal to? Mass divided by volume. So, could I put M over V, let's see, RT? Let's just make this so we don't get confused. Let's make that, since it's mass, let's make that a little m, so I don't get a big M and a little m mixed up there. Little m. Could I do that? Mass over volume instead of the density? Yes, you're going to need to be able to do that. You will have to do that sometime or other when you are dealing with this. I've seen it before, so you will see it probably. Okay?